Yes.
How would you plant a scallop?
How would you plant them? Well, this is one way that we do it, is we put them into these nets, okay? And these are all hatcheries that are grown at the lab, at Cornell's lab that we just met at, okay? So that's one major strategy. The other is to just basically, we get them in these fish totes and you throw them off the boat. It's actually quite fun. It's like planting corn seeds, you know. And you know, we know how many scallops we have, and we know what area we're planting in, so we get an idea of the density that we plant. But those are the two major strategies: putting them into nets and then releasing them directly to the bottom. Now, when we were doing restoration back in the late 80s, early 90s, most of the effort went into releasing them to the bottom. Okay, and back then we were concerned that by putting lots and lots of them in there, that it was going to attract predators like crabs and starfish and things like that. So we actually planted them at like 10 per square meter, right, which is a fairly low density. Now we plant them at 100 per square meter. All right, and the idea is that once they get to spawning time, that there's going to be enough together that when the eggs are released, that they're going to get fertilized. All right, so that's been our underlying hypothesis behind this all. Okay, so I mean, it was a roll of the dice. We didn't know that this was going to work. Our funding agency, you know, was they really took a gamble on the project, and they knew that nothing was guaranteed. So what we did was we built up the infrastructure to be able to produce millions of scallops, and so the science part of it, we collected 2 years of data before we did the restoration work. So we went around, we dived in the bays all around here. We looked at populations on the bottom. We put out mesh bags to collect scallop larvae when they settle out of the water to attach to, so we knew what kind of larval recruitment was going on. So we have 2 years of data before restoration, and now we have 3 years of data afterwards. Okay. So what we've seen is a tremendous increase in the populations since we've been doing the restoration work. Right now, we're up at population levels that are anywhere from 40 to 100 times higher than what they were before a restoration work. All right? And the reason I can stand here and say that we think it's due to the bay scallop restoration efforts that we've been doing is because we also had some control sites where we didn't do any plantings, where we looked at the settlement of larvae onto these mesh bags, and we looked at what was on the bottom, and it did not change. And it only was changing in the areas where we had either done our plantings or where there were higher populations where the densities were a little bit better. Right? So we've seen a tremendous increase, and Ben will tell you that the harvest now in the last 2 years has been the best since it was in 1995. So things are starting to come back, and we're very excited. In our fall population surveys, we saw, I saw more scallops than I've seen in 20 years. And so we're really hopeful that, you know, this trend's going to continue and that the fishery's going to hopefully come back to close to what it used to be. And because of the value of the fishery, I mean, that's been our ultimate goal of this project, is to bring the fishery back. So far, so good. You know, we think we're getting to the point now in the natural populations where the densities are getting up to the point where fertilization is taking place successfully in many, many populations throughout the bay. So we're reaching what we like to call a critical mass. And once you get to that critical mass, then, so we're hoping we're going to see this population explosion like we saw in 1993, 1994. And that's what we're after. So this operation, this is a very labor-intensive operation. Kevin and Josh and Jeff from the lab are the guys that are in charge of this. And this is a system that's adapted after Japanese aquaculture techniques. The Japanese developed all these techniques, these nets. The whole way of doing this is basically, we copied this from the Japanese, and as people have done all around the world. So the idea here is that the scallops are grown in a hatchery, okay, at the lab that we left from, and then gradually, as they get bigger, we put them into nets that have larger meshes. Okay, so these nets are 12 millimeter mesh, and scallops go in at a size of about 25, 30 millimeters. All right. So the idea is that we put these in the fall. They live in there over the winter, and then when spawning season starts, which will be in late May, beginning of June, then these guys will all be close together, and then we'll get fertilization success. So in all of these nets, all of these lines, we have close to 3,000 of these nets, okay, and over 500,000 scallops were stocked into these nets in the fall. Okay, so normally by the time we get to spawning season, we get about 50% survival. All right. Now, one of the things, as you can see, a big difference here. These are nets that have already been changed out. That is that we have to change them over from the dirty nets into the clean nets, because if you get all of these fouling organisms on here, what happens is it restricts the flow of water through there. They don't get as much food as they need.
What is that on?
Most of what's on here is algae. Okay, this stuff here, this is locally referred to as slip gut. All right, and it's algae that grows mostly during the winter time, and as it gets warmer, it actually dies off. Okay.
Slip gut.
Anybody want to see slip gut up close and personal? Okay.
I want to touch
There's all kinds of stuff that grows on these nets,
Oh,
and
guts.
we're going to haul some nets up so you
Slippery
get to
guts.
see what this looks like.
Lick it.
Okay. Okay. So, anybody have any questions?
Oh.
Yeah.
You said that was it a quarter of the scallops are grown in Long Island?
No. At one point,